All right, so if you think about your notes from last night, I told you guys that, are we ready? We're going to do adding and subtracting fractions a little bit differently than how you learned in middle school, because the fractions that we're dealing with are a lot more complicated than what you learned in middle school. You guys remember that? Well, elementary school, I guess, when did you learn how to add fractions? Elementary? Okay. So what we're going to do, if you guys remember, as I said, we're going to factor the denominator. We're going to look at what multiplies to give you that denominator. I'm going to ask you for today to show every single step that I show. Do not shortcut anything today. Not because you can't eventually shortcut it, but because I've taught this concept for 7 years. And this is what I have found makes the most sense to students. So if you start to shortcut things, you're not going to get the best way to learn how to do this. Okay? So don't shortcut anything today. If I write it, I expect you to write it. Make sense? Yes. Okay. All right, so what is 5? If I were to factor 5, what multiplies to give you 5? 5 and 1. And typically, we're not going to write down the 1 because it's kind of silly to say something multiplies by 1 because everything does. How about 2y squared?
2 times y.
So 2 times y times y. So then for our common denominator, yeah, there. Did you already get one?
The one that's up here?
Yeah. You're gonna. All right. So now if we look at, these are all the pieces in our denominators, what does our common denominator need? It needs a? It needs a 5. It needs a 2. And it needs 2 y's. So that means that our common denominator is 10y squared. So that's the first half of our answer, because if you look at the instructions, they ask you to find the common denominator, so we just found it. The second part of the instructions ask you to write down what each fraction needs. So here's the work that I do to see what each fraction needs. I say my left fraction has a 5. So up here, I cover up the 5, and then the stuff that is left is what the fraction needs. So what does it need? 2yy. So 2y squared on the top, 2y squared on the bottom. The right fraction has a 2, a y, and a y, so I cover those up. So what does the right fraction need? 5. 5 on the top, 5 on the bottom. That is the only thing the instructions ask you to do, so we're done. We move on. This is such a big idea as far as math goes. It's not like you grin and bear this unit and you get past this unit and you forget it forever. It's like we make sure that you understand how fractions work this unit, and then in pre-calc we work with fractions some more, and then in calculus we work with fractions all the time. So this is one of those things that's kind of like factoring, where it's like annoying, but it's very repetitive. Have you guys noticed that about factoring? Mm-hmm. And once you learned how to factor, we just keep factoring. We've started to factor in all sorts of different units since then. That's the same thing with this. It's annoying, but not necessarily impossible. It's going to be very repetitive, and we're going to use it with math starting now, and then forever after this. We're going to see fractions all the time from here on out. Does that make sense? So our goal is not just to get through each day. Our goal is to understand what we do, because we know that in future math classes we're going to have to be really good at this stuff. Okay? So ask a lot of questions as you have them. All right, number 3. How can you break down this denominator? Yeah, so 2 times 2 times x times y. How about this one? 2 times 2. Okay. So our common denominator, how many 2's does our common denominator need? Think about common denominator. You only need 2 of them. So when I look at this, I just have to have as many so that whichever fraction has the most is covered. These fractions both happen to have 2 2's, so all I need is 2 2's. If one fraction had 1 2 and another fraction had 3 2's, then I would have needed 3 2's. If one fraction had 2 2's and one fraction had 8 2's, then I would need 8. So whichever fraction has the most, that's the one that wins. Does that make sense? So here, since both of them had 2, that's all I needed. What else do I need for my common denominator?
X and y.
An x and a y. So what's our common denominator? 4xy. Okay. And then to figure out what the fractions need, I'm going to say this one has 2 2's and it has an xy. So what does it need? Nothing. It has it all. The second fraction has 2 2's. So what does it need? XY. Okay, let's try number 4. So what's the first denominator? Okay. And then what's the second denominator? 1, 2, 3. Okay.
So do we only write 1, 2 down for this one?
So why would we only write 1, 2, and not 2 of them? Yeah, each fraction only has 1. So we just have to look at how many each fraction has individually. So we need 1, 2. What else do we need for our numbers? We need a 3. Okay, so what is our common denominator overall? Yep. And then for us to figure out what each fraction needs, I'm going to cover up what I already have. So I already have a 2, and I already have an xxx. So what do I need? 3y, 3y to the third. All right, this one has a 2 and a 3 and a y. So it needs the x to the third. How are your brains? Does it make sense what we're doing so far? So what's like the first step to approaching the problem? Yeah, spread out the denominator, right? See what each of the little pieces are for the denominator. Then how do we find our common denominator? Yeah, we make sure we have each of the little pieces, right? Does that make sense? Each of the little pieces. And then I think the hardest part is figuring out what each fraction needs. How do we figure out what each fraction needs? Yeah, cover up what it has. And then the leftovers are what it needs. Okay. I want you guys to try 2, 5, and 6. That's what we're doing right now. 2, 5, and 6. So go ahead and work on those for a little bit. 2, 5, 6. Go ahead and take a moment and check your answer for number 2. It has to be the same on top and bottom. Whatever you do to the top, you have to do to the bottom. So I don't look at the top. I don't care what the top says. I just look at the bottom had a 2. So I cover up a 2. And then it needs 2xy squared. And whatever I put on the bottom, I have to put on the top. It is. There's a square right there. We all get 2 right? Yeah. We get 2?
Would he give to you?
Yeah, I got it.
All right, go ahead and check your answer for 5. Can we get number 5?
Yeah, buddy.
Yep. We good?
Yeah, play 2 twos instead of 2.
So how many twos? How many twos did I need? 2 twos. Why did I not need 3?
Because 2 is the max.
2 is the max that you can see on one side. Now, you could still get the right final answer at the end if you had 3 twos in there. It would just mean that you've made the problem a little bit more difficult for yourself. You're going to have some extra simplifying to do. So it's always good to make the smallest common denominator that you can, because it makes your job easier once you have to go back and simplify at the end. That's the motivation for that. What does the left fraction need? It has a 2 and a 3. So what does it need? Yeah, 2mn squared. The other denominator has 2 2's, an m, and an nn. So what does it need? 3. And you'll notice one thing is I never looked at the numerator. I could care less what the numerator says. All I care about is getting a common denominator, and that means I only look at the denominators. Did you guys notice that? I never once even read the numerators out loud. I didn't care what they were. Okay? All right. How do we feel about 1 through 6? Because we're about to move on to a different type of denominator. Are we okay with those?
Can you go back to 5?
Yeah.
5 seconds. Why did you take the 3x over there?
So when I looked at this denominator, I could see a 2, and a y. And when I looked at this denominator, I saw 3 and an x. So I made sure my common denominator had everything. And then when I was looking at this one, I said, okay, it's got a 2, and a y. So it needs a 3 and an x to be the common denominator. So that's why I was like, oh, 3x, 3x.
All the way down there.
And then this one had the 3 and the x. So it needed the 2, and the y. So I multiplied by 4y and 4y. All right. Number 7. What is different about number 7? The denominators. It's got a plus in it. So now when we factor it, we can't factor it like this one. This one's one of the easy ones, right? That's 2 times x. When I factor that, that's pretty easy. This one is the type of factoring that's a little bit more complicated. This is like high school level factoring. So what are the types of factoring that we've learned in high school? GCF, difference of squares, diamond. So what type of high school level factoring do you have to do for this one?
GCF.
GCF. It's a GCF problem. So what do you see? What's the greatest common factor? 2 and an x. Good. So 2x times... Okay, is that where it is? That works?
Yeah.
Okay. So when I think about this as like how many pieces do I have a 2 that's all by itself. That's this one in the front. I have an x that's all by itself. That's that x in the front. and then I have a whole group, and that group is 2x plus 1. So this 2 and this x in the front and the 2x inside here are two totally different 2x's. One's a 2 all by itself, one's an x all by itself, and then this is a 2x plus 1 as a whole group. That's a whole thing. All right, so our common denominator needs, it needs a 2, right? It needs an x, and it needs a 2x plus 1. It needs the group. So we're going to say that our common denominator is 2x times 2x plus 1. Whenever we have a common denominator that's written with parentheses as its factored form, we're going to go ahead and leave parentheses in our common denominator. For today, it doesn't make a lot of sense, but later on in the unit, you'll be like, ah, yeah, I like it when it's factored. Okay. It helps you to be lazy in the future, which is always a good thing. Well, not always a good thing, but a good thing always. All right, so if we look at the first fraction, it's got a 2, it's got an x, it's got the 2x plus 1, so what does it need? Nothing. The other one has a 2, and it has an x. It needs the group, the 2x plus 1, and since that was a group, I'm going to put the group up here. Okay? I want you to use number 7 as a model, and I want you to try number 8. Use number 7 as a model, and then try number 8.
No.
Anyone want to share what your GCF was?
2x.
And then what do we have?
2 times x times x minus 2.
So, what did our common denominator need?
X minus 2.
Needs the group, x minus 2. Okay. Okay, so it needs an individual 2. They both have individual 2's. It needs an individual x, and then it needs the group x minus 2.
Big facts, big.
It doesn't need 2x.
It does. So it needs an individual 2 because they both have that. It needs an individual x, and then it needs the group x minus 2. All right. So what does the first fraction need? It needs the x and it needs the group. So we cover up the 2. It needs the x, and it needs the group. It needs the x and it needs the group. How about the other one? What does this one need? Nothing. It has the whole thing. Okay. Go ahead and... Oh, let me write my common denominator. All right, go ahead and flip your paper over. There's a back. All right. Now, look at these denominators.
Holy.
Can you factor a plus 3?
Yes.
No, that's like a group on its own, right? That kind of looks like a factor already. So we're going to say that this is kind of like, it's kind of like if you had 5 on the bottom and I asked you to factor 5, you'd be like 5 is a prime number. So it's just 5. This is a group, but it's like a prime group, so it's just a plus 3. That's the whole thing. Yeah, you can't separate them because there's a plus sign in there. Because factoring, when you factor, you're looking for things that multiply. And since it's a plus 3, you can't factor that. The other one's going to be a minus 6. So if you think about your common denominator, what would your common denominator be?
A plus 3 times
A plus 3 times a minus 6. You have 2 groups that are different. And so your common denominator needs to have both of the groups. So this is kind of like back in the day, if you had a fraction with a 5 underneath it and a fraction with a 7 underneath it, you'd be like, well, 5 and 7 have nothing in common, so my common denominator is 35. Multiply them together. Same thing like this. They have nothing in common. Even though they're both the same letter, the groups are completely different, so we need one of each group. So if this denominator is a plus 3, then what does it need to have the common denominator? It needs the a minus 6. If this denominator is a minus 6, what does it need?
A plus 3.
Plus 3. Okay.
So the common denominator just doesn't matter.
Yeah, and our common denominator, again, if it's written in factored form with parentheses, I want to leave it in factored form with parentheses. I do not want to FOIL it out. And that's because when we do all the stuff that we've done the first 3 days of this unit, we've always factored and canceled. We like factored form. It makes canceling easier.
Nice.